Okay, so let's move on to the notes and then also the next homework. So for these notes, we're actually going to be using the factoring and square root property to be able to solve this. This is just kind of a review to do quadratics with perfect squares and trinomials. This is not what we're going to be doing today, but it's just a review of kind of using different methods put together. So if we look at number 1, what I'm going to do is I'm actually going to factor first. So I'm going to factor this here. Remember, your a is equal to 1. That's what you want. So what times what gives you 49, but also 14. So 7 and 7. So I'm going to factor. So x minus 7, x plus 7 and x plus 7. That equals 4. Now, remember that you can rewrite this as x plus 7 squared because it's the same thing. Now that I've done this, I've done the factoring part. Now I'm going to go ahead and use the square root method. So just like when I do, let's say if I give you something like this, notice how that x is squared. You're going to take the square root, and that's how we're left with plus and minus 4. Well, that's what we're going to do again, or that's what we're going to do for this one. So notice how it's squared. I'm going to take the square root, which is going to be x plus 7 only. And I'm going to take the square root of 4, which is just 2. And then from this one, or plus and minus 2. And then from this one, I'm going to go ahead and subtract the 7 from both sides, which gives me x is equal to negative 7 plus or minus 2. But notice how these are technically like terms. Okay, so I have two cases. I have where x is equal to negative 7 plus 2, or I have where x is equal to negative 7 minus 2. So in reality, your answer here is both negative 5 and negative 9. Okay. Now, the only reason I was able to do that is because this is a plus and minus 2, and the negative 7, that's a normal number. It's a constant. Just like 2 plus and minus 2, that's still a normal number. Now, let's say that this had an I, like a 2i, then you can't combine them anymore because this negative 7 does not have an I. Let's say that one of these has a square root. Like, let's say this was 2 square root of 5. You cannot combine them again because they're not like terms. So now let's look at number 2. For number 2, same thing. Let's go ahead and factor first. So right here, notice how a is equal to 1. That's the perfect one. So what times what gives you 9, but also negative 6. Okay, so you're gonna use that, and it's actually negative 3 and negative 3. Notice how I'm always getting the same thing. So see how that was 7 and 7, negative 3 and negative 3. That's a good sign. Okay, so then we have x minus 3 is equal to 20. I'm going to rewrite that with the square. But remember, now I'm going to take the square root because I'm doing the square root method. So I'm left with x minus 3 is equal to, now 20, you can break that up by 4 and 5. 4 is a perfect square, so we're going to get plus and minus 2 square root of 5. Now I'm going to add 3 to both sides. However, this is what I'm left with here. Notice how this has a square root of 5. You cannot combine it with this. It's like, they're not like terms, so you can't combine them. So for this one, this is actually your answer. Okay, you don't do separate cases like this one. Alright, so let's look at the next one. Alright, so for this one, we're going to do completing the square. Now, you guys kind of did something similar to that with vector or vertex form, where we were completing the square. This is a way of solving a quadratic with completing the square. What you guys did was how to write a quadratic in vertex form using completing the square method. But even though they're both completing the square, they're used slightly different. So just be mindful of that. So let's look at this one. We have these 6 steps that we need to follow. Okay, step 1 is to rewrite it as ax squared plus bx is equal to c. Your c has to be where on the other side of the equal sign. You're going to divide both sides by a so that your a becomes just x squared. So basically what they want is they want the a to equal positive 1. If it's not a positive 1, you're going to have to divide it by a. Otherwise, even if you divide it, it doesn't really change anything if it's already a positive 1. So number 3, you're going to go ahead and complete the square by taking half of b, so that should sound familiar, squaring it, adding it to both sides of the equation. Factor the perfect square trinomial, take the square root to both sides and create 2 cases if possible. Sometimes you won't be able to, just like on the examples we did. So you're going to solve and simplify. Now, these examples that I'm going to be doing are similar to the first two that I introduced you to, but there's more to it. It's not as quick as those. So let's take a look at number 3. So first things first, I'm going to rewrite it so that it's equal to c. So x squared minus 18x is equal to negative 56. So I'm done with that step. I'm going to divide both sides by a so that it becomes x squared. But if you look here, this is already x squared, because my a is a positive 1. So even if I were to divide all of this by 1, because that's what technically your a is here, nothing will change. So I'm not even going to bother doing that. So now I'm good with step 2. Complete the square by taking half of b. Remember, half of b is negative, so negative 18, half of that is going to be negative 9. You're going to square it, that's 81. So you're going to be actually adding 81 to both sides of the equation. So x squared minus 18x plus 81 is equal to negative 56 plus 81. So this is the difference from the last time with vertex form. You're not having to multiply. The 81 will always stay positive. You're adding it to both sides of the equation. So now we're going to go ahead and factor. So if you look at here, your a is 1. That's what you want, okay? So now what times what gives you 81, but also negative 18? That's negative 9 and negative 9. Again, notice how these are always the same thing. That's what you're going for. So x minus 9 and x minus 9. So I'm going to just take a shortcut and do the square. Or you know what, I'll write it out the first time. X minus 9. And then we have 56, negative 56, and positive 81. So we get positive 25. Now I'm going to rewrite this by x minus 9 squared is equal to 25. Take the square root. You're left with x minus 9 is equal to plus or minus 5. I'm going to add 9 to both sides. Now, because we have 9 plus 5, we can combine those. There's nothing that tells us we can't. So I'm going to be left with 14. And then you also have 9 minus 5, which is going to give you 4. So these are your two answers here, 4 and 14. Okay. Let's look at number 4. I'm going to help you start number 4, but I'm not going to do it. Okay. So now, first things first, rewrite it so that it is equal to c. So ax squared plus bx is equal to c. So I'm good. I don't even have to do anything anymore. So I'm done with step 1. Step 2, it says divide everything by a. Your a value here is a 2. Earlier it was a 1. That's why it wouldn't really matter. But now that your a value is something other than a positive 1, it's going to matter. So now this is what we have. So we're left with x squared minus 8x is equal to negative 15. So now that you've done that, you're going to complete the square by taking half of b. Half of b is, you're taking it from that negative 8. Okay, so go ahead and keep going. Square it, add it to both sides. Check your work. Alright. Let's look at 5. So I'm going to do 5 and 6 because they involve fractions and I know how much you guys love them. So first things first, you're going to make sure that it's set equal to c. So 4x squared minus 8x is equal to negative 3. I'm good. Next thing, I need to divide everything by 4. By a. Notice how your a is a 4 here. That means it will matter. Okay, so it's going to change things. So I'm going to divide by 4. I'm left with x squared minus 2x is equal to negative 3/4. I don't want a decimal. I'm going to be working with fractions because we need to keep those fractions. So now from here, I'm going to take half of b and add it to both sides. And this is where the fun fractions stuff happens. So half of b, so we're looking at negative 2. That's negative 1 squared. So that's 1. So I'm actually adding 1 to both sides. Okay, you're going to factor. Now, remember the goal is to have the same thing 2 times. If one's positive, one's negative, you're doing something wrong. So what times what gives me 1, but also a negative 2? So that's going to be negative 1 and negative 1. But I'm going to square it, okay, because it's going to be negative x minus 1, but I'm not going to waste time doing that. Now, over here, I have negative 3/4 plus 1. I'm going to set 1 as a fraction. Now, I have to get common denominator, so I'm going to multiply the top and bottom by 4. I'm left with negative 3/4 plus 4 over 4. This is actually 1/4 here. Okay, so I get 1/4. So now from here, I'm going to go ahead and take the square root of both. So this is going to be x minus 1 is equal to. Now, some of you might freak out and see, whoa, what's up with this 1/4? But the 1 and the 4, they are both perfect squares. Okay, so look at them separately. What's the square root of 1? Well, it's 1. And then what's the square root of 4? Well, it's 2. So you're going to get 1/2 here. Okay, because basically what you're doing is this. Okay, so 1 over 2. But it's going to be plus or minus. Now, the next thing you do is you're going to add 1 to both sides. You're going to be left with x is equal to 1 plus or minus 1/2. Now, remember that you're going to have to have two cases because you can combine these. And hopefully you're able to do 1 plus 1/2. And you're also able to do 1 minus 1/2. But in case you're not, I'll help you. 1 plus 1/2, same thing. Denominators. You're going to be left with 2 over... Whoops, that is not what I wanted to do. 1 plus 1/2, common denominators. That's what I wanted to do. So 2 over 2 plus 1/2, that's going to give you 3 over 2. Okay, so the first answer is 3 over 2. Then you're going to do 1 minus 1/2, same thing, common denominators. 2 over 2 minus 1/2, you're left with 1/2. So then these are your answers. Okay, I need to see your work for the fraction. Okay, let's go ahead and look at number 6 now. 6 has a lot of fractions going on, so bear with me. Okay, so first things first, you want to set it equal to c. -8. And then you are going to divide everything by 3 because that's your a. Now, it's fine, we got fractions here. Now you're going to go ahead and take, so I'm left with x squared plus 10x over 3 is equal to -8/3. So now it's telling me to take half of b, so 10 over 3. You're going to take half of that, which means you're going to divide it by 2. But I'm going to rewrite that as 10 over 3 times 1/2 because of keep, change, flip. So we get 10 over 6. Let's simplify that to get a smaller number. I know it seems like a lot, it's just because we have fractions, so we get 5/3. That's what you're going to be squaring, which will give you 25 over 9. So that's what we're going to be adding and subtracting. So x squared plus 10x over 3 is equal to negative, whoops, I forgot to add 25 over 9. -8 over 3 plus 25 over 9. Now from here, we have to figure out what times what gives me 25, but also 9. So it has to be the same stuff. So, okay, what times what gives me 25? Well, that's 5. What times what gives me 9? That's 3. So it's actually 5/3. Now check them. Does that give you 10/3? So these are common denominators. What is 5/3 plus 5/3? That is 10/3. So then that's the one that you're working with. So x plus 5/3, and that's squared, is equal to, let me move this. Now you need to go ahead and find common denominators to add my -8/3 plus 25 over 9. I need to get common denominators, so I get -24 over 9 plus 25 over 9. That's going to give me 1/9. So I get 1/9 here. Now we're going to take the square root. I'm left with x plus 5/3 is equal to 1/9. Or sorry, 1/3. Because you take the square root of each. Okay. Plus or minus, sorry. Then you're going to subtract 5/3 from both sides. We're left with x is equal to -5/3 plus or minus 1/3. Now you have to do both cases. The good thing is they're already common denominators. So -5/3 plus 1/3, that is going to be -4/3. And then we have -5/3 minus 1/3, that's going to be -6/3, which will simplify to -2. And then that's your answer. So there is fractions, but they're not that difficult. Alright. So now you guys can do those. Remember, when you have square roots, you can't combine them. That's probably why this ends up being your answer. But I want to do, oh, that's lots of them. I will do number 10 with you. Okay? So we know what our answer is going to be. Alright, so 10, you're going to set this one equal to C. Notice how it looks like it's equal to C, but it's actually equal to BX here. So we're actually going to have to move things around. So minus 16x and minus 76. So we're going to move things the other way. So 4x squared minus 16x is equal to negative 76. Now I've done what I need to do. I'm going to go ahead and divide everything by 4. X squared minus 4x is equal to, okay, and I'm going to be left with negative 19 here. So now from here we're going to take half of b, square it, and add it to both sides. Alright, so we're going to figure out what times what gives me 4, but also negative 4, so that's negative 2. Notice how it's the same thing, so that's why I'm squaring it. This should be 4, not 14. And now you're going to go ahead and do the square root of both sides. X plus 2, or sorry, x minus 2 is equal to the square root of negative 5, or the square root of negative 15. Remember that if it's a negative, you take out an I. So this is actually this, okay, plus and minus. Now the 15, can we break that down? It's only 3 and 5, so there's nothing. So I'm going to be left with x. I'm going to add 2 to both sides first, and then I'm going to be left with x is equal to 2 plus I over, or times square root of 15. You cannot combine those two, so then you're done, which matches this answer. Okay, so you guys will do the other ones. Please be careful and make sure that you're setting it equal to C, okay, because like on number 10 you guys saw that was not C. On number 7, you're going to have to set it equal to C. They're both C right here, which means you're going to have to add 21 first, okay, and then get your new equation here, which will be 16. So go ahead and keep going, check your answers. I gave you the key. Have fun.